Hello students, now in today's lecture we will discuss the silicon controlled rectifier. So one has to know what is silicon controlled rectifier or how its name comes from. So silicon controlled rectifier, it is a semiconductor device which is made up of silicon only and it is PNPN device. As in this figure it shows it is PNPN device, or it is visualized as the normal rectifier plus NPN transistor. Normal rectifier as a PN junction plus NPN transistor. It is nothing but the silicon controlled rectifier, and the process of rectification is done by externally the entities like the voltage applied across the anode and cathode or across the gate and cathode terminal. So as the silicon controlled rectifier is a PNPN device, the outermost P region at which the contacts are drawn, it is called anode terminal. The middle P region from which the contact is drawn is called gate terminal, and outer N region from which the terminal is drawn, it is called cathode terminal. So it is about the construction of silicon controlled rectifier, in which there are three different junctions. This is junction J1, this is junction J2, and this is junction J3. So this figure 1 shows the construction of silicon controlled rectifier, and this figure 2 shows the symbol of silicon controlled rectifier. This silicon controlled rectifier is invented in 1957. In 1957, and it is used as controlled switch, that is by controlling the output across the anode and cathode terminal, or the controlling the voltage across the cathode and gate terminal, the switching can be controlled. This silicon controlled rectifier is also used for process of rectification, and also it is useful as inversion regulation of the power flow. So now we will discuss the working of silicon controlled rectifier. So this silicon controlled rectifier may work in two ways. First is when gate is open. So the next point is working of SCR. Working of SCR, that is silicon controlled rectifier. So this silicon controlled rectifier may work in two ways. First is when gate is open. When gate is open. So this is junction J1, this is junction J2, and this is junction J3, and load is applied across anode and cathode terminal. Load resistance RL is applied, and positive terminal of battery is connected to anode. And the negative terminal of the battery is connected to cathode terminal. And as in this case the gate terminal is open, so there is no any voltage is applied across gate and the cathode. So this is a circuit diagram for the case when gate is open, that is this is a gate terminal and this is the cathode terminal, and there is no any voltage is applied across gate and cathode, or this gate terminal is visualized as open, and the positive terminal of the battery is connected to anode and negative terminal is connected to cathode. As this is a P region, this is a N, this is again P, and this is N. So due to application of this positive terminal of the battery to the anode, this junction J1 becomes forward biased. Also due to application of this or connection of this negative terminal of the battery to the cathode, this junction J3 is also in forward bias, while this junction J2 is in reverse bias. So junction J2 is in reverse bias, and junctions J1 and J3 are in forward bias. Forward biased. When the positive terminal of the battery is connected to the anode terminal and negative terminal of the battery is connected to cathode terminal. So in this case this region is visualized as NPN transistor, in which base is open. So as here gate terminal is open, or there is no any voltage is applied across gate and cathode, so this region is visualized as the NPN transistor, in which base is open, and as the voltage across the anode and cathode is increased further, this junction J2, as it is in reverse bias, the reverse bias junction J2 breaks down as voltage across this battery is increased, and due to breakdown of the junction J2, the SCR starts conducting heavily, and this is the on state of silicon controlled rectifier. Here one has to look after the concept, that is breakdown voltage. The applied voltage on which silicon controlled rectifier conducts heavily without gate voltage is called the breakdown voltage. So this is the one of the way in which silicon controlled rectifier can work. Then we will see the next way, that is when gate is positive with respect to cathode. When gate is positive with respect to cathode. So in this case also load resistor is applied across anode and cathode. Again, positive terminal of the battery is connected to anode terminal and the negative terminal of the battery is connected to cathode terminal. And some potential is applied across the gate and cathode. So here positive terminal of the battery is connected to gate terminal and negative terminal is connected to cathode. So this is called, the gate terminal is positive with respect to this cathode terminal. This is P region, this is a N region, this is again P region and this is N region. This is junction J1, this is junction J2 and this is junction J3. So when the gate is positive with respect to cathode, again the junction J2 becomes reverse biased, as here potential across this anode and cathode is large as compared to this potential. So in this case also this junction J2 is reverse biased. Junction J2 is reverse biased. And junction J1 and J3 are forward biased. So as here the potential applied is large and the positive terminal of the battery is connected to anode terminal, and negative terminal of the battery is connected to cathode terminal. This junction J1 is in forward bias, so junction J3 is in forward bias, while the junction J2 is in reverse bias. Due to application of or connection of this positive terminal to the anode and negative terminal to the cathode, here holes will move in this direction and electrons from this n region will move in this direction. So when we take into consideration the junction J2, then there will be a motion of electron towards the left side from this n region to this region, and this electron will move or approach towards this junction J2, while due to application of this or connection of this positive terminal to the anode, holes from here will move towards the right, and here holes will move from this P region towards the right side. And due to motion of these electrons towards the left side and holes towards the right side, again the junction J2 breaks down. So, and silicon controlled rectifier has two states, that is either it does not conduct or it conducts heavily. So, there is no any state in between the on state and off state, or in between the conducting state or non-conducting state. Therefore, silicon controlled rectifier behaves as a switch. Then next point one has to take into consideration is that there are two ways to turn on the silicon controlled rectifier. First one is to keep gate open and make the supply voltage equal to breakdown voltage. So in this way the junction J2 will break down and silicon controlled rectifier will start conducting heavily. The next one is to operate silicon controlled rectifier with supply voltage less than the breakdown voltage, and then turn it on by means of a small voltage applied to the gate. So here the applied voltage to the gate is of the order of, or which is nearly equal to 1.5 volt. So when small voltage is applied to the gate, the SCR can start conducting heavily. Applying a small voltage to the gate is the normal way to close the silicon controlled rectifier, because the breakdown voltage is usually much greater than that of the supply voltage. And the next point one has to take into consideration is that to open the silicon controlled rectifier, that is to make it non-conducting, reduce the supply voltage to the 0. So in this way the silicon controlled rectifier may work. So with this I will stop here. In next lecture we will see the equivalent circuit of SCR, then use of SCR as a switch and as a rectifier. So thank you here.